my median is 5.5. Let me see if I can stat calc this and then, because it doesn't ask. Second L3 maybe. Yeah. Okay, so if you type in your list value after one variable stats, it comes up with the mean for you here. And then when you scroll down, you can find the median. Okay, so I'm going to write all those steps down for you. And then if you have questions or want me to run through anything, let me know. Let me unbrighten this so you can see it again. Okay, so to find mode, we need to sort our data. So you click Stat, Sort A, and you type in your list value. Normally we would use L1. And to get that L1, you do second 1. If you're looking for a different list, you would do second like L or second 2 or second 3, whichever one you needed. Then to find your mean and your median, we do stat, edit. You enter your data. Oh, that's where you enter your data. Sorry. I guess that should have been the very first thing. Then stat, calc, and you click on one variable stats. And this will come up with your mean and your median. Okay, and that's what it's coded as on your thing. So you can go ahead and, so for, I guess I'll cross out this first column because we didn't use it. Our median was 8. Our mean was 10.07. Oh, I'm sorry, our mean was that. And our mode, I'll have to go back and look at. Go back and look at it. So we have 3 7s. I think that's it. So 7 for doing the second column of data. And we just did the second column just to save time. You could have done all of them. What questions do you have? One key thing, we didn't include any of these numbers because she numbered the students off to tell you how many total students there were, but you don't use those to figure out the data for the weight of the backpack. Okay, any questions? Okay, I'm going to move on if there are no questions. Somebody's mic is on. Does that mean that you have a question? I think it's Layla. Okay, so I'm going to move on. So there's a discussion question here. It says, though Kiera does not include every student in the school, is her data a good representation of the weights of student backpacks at school? What do you guys think? Kelly, tell me what you think.
I think it is because she chose the students randomly. It's not like she chose like a specific class or anything.
Okay, so chosen randomly is like a pro for her data. Okay, but what if there are like 2,000 kids at the school? Would 30 of them be a good representation?
Probably not, because I remember like more people you have in your study less of a margin of error you have. So
Exactly.
I feel like she could have done more.
So because she chose them randomly, that's great, but it depends on how large the total population of the school is. Okay. Oops, sorry. The three values commonly used to describe data, the mean, median, and mode, are called the measures of central tendency. Also, I'm pretty sure I spelled tendency wrong, but whatever. Okay, questions on the front side of this page. I will be posting the final copy of these notes, so don't worry too much if you don't finish. We have a little less than 15 minutes, so, and we need to get through the back of this. So we should probably move on. Okay. Okay, so we have some examples back here. So we have in example 1, the results of a survey of the age of 110 cars passing at a particular point are defined in the given table. So this is a frequency table. And so we have.
Can you straighten it, because we can't see the top?
Okay, so this is a frequency table. So we have a range of ages here, okay? And our frequency is defined down here. So there were 15 cars that were between 1 and 2 years, okay? Now, when we're finding the mean for data like this, we do it by taking the age, or whatever the data is looking at, sorry. So we're going to take the sum of the age times the frequency, okay? And then divide that by the total number of data points. Okay? Now, our age was given in a range, 1 to 2 years. So when we take our age and multiply by our frequency, what we really want to do is we want to multiply by our average age. So we want to change this to 1.5. Okay, change this to 2.5, 3.5, 4.5, and 5.5. Okay. So we're going to have 1.5 times 15 plus 2.5 times 27 plus 3.5 times 36 5.5 times 11. And we would divide that by the total number of data points. Who knows how you would get our total number of data points for this type of frequency table? Layla. If this is how many times each of those types of cars passes, how would I get the total number of cars that pass?
You add that all together.
Yeah, good. I would add them all together. So this would be, it ends up being 110 when you add all those numbers. Okay. And I'm just going to go ahead and tell you that this comes out to be 3.37. Okay. You could also do this in your calculator by making this L1 and this L2. Okay. And the modal class, I'm going to put a definition at the bottom of the paper, but modal class is talking about when we have equal class intervals. So we have each of these has 2 ages, like it covers a year of the age. So we have equal classes of data. It's asking which of these particular classes has the most. So what would be the modal class for this particular data set, Ted? Which one had the highest frequency?
3 to 4.
Yeah, 3 to 4 years. Very good. Okay, what questions do you guys have on that example?
This might be a stupid one, but where did 1.5 and 2.5, all those numbers come from?
No, that's not them. So we have these age ranges here, right? And so it would be difficult when we're figuring out the mean to like use exactly 1 or exactly 2. And so we just use the average of those 2 values and pick 1.5. So when you have a class of data like this, just use the average since it's a group instead of specific values. Okay. We are going to skip example 2 because of time. So we're going to write out our mathematical formula for mean. Okay. It's going to be the sum, and we kind of wrote this out already for example 1. It's the sum of each of the values, so the f values times x, all divided by the sum of f. Okay. And the sum of f is just the total number of data points. Okay, so here it asks us to calculate the mean of a set of data. You guys should all know how to do this. 3.7 is listed once. We multiply by 1. 4.2 is listed once. 4 is listed once. 2.5 is listed once. And then we would divide by the total number of values in there, which would be 4. And you'd get a value. Okay. For the sake of time, since we have like 7 minutes left, we're going to jump to the mean of the frequency distribution box. Trying to get through it as fast as possible. And the last section should have hopefully been review. Okay, so the lengths of stems of a group of 35 plants were recorded to the nearest 5 centimeters, and the data was recorded in the table. So they have the length of the stems of the plants, and then we have the frequency of each of those lengths. So to figure out these pieces are just asking for these pieces of the mean formula. So this one corresponds to the numerator, this corresponds to the denominator. That's all it's asking. Okay, so for the sum of f sub I, it's just asking for the total of all the plants they looked at. So what should my total be, Megan?
$35.
Very good. So this is 35, and this is my denominator. Okay, from my mean formula. Now for these, this is f times x. Okay, that's all it's asking you to do, and then add them all up. So we're taking f times x, and then we're going to add all those values up. So I'm going to have 6 times 10, which is 60. Then I'm going to have 12 times 15, which is 180. Then 13 times 20, which is 260. And 4 times 25, which is 100. When you add all of these values together, I think that you get 600. Okay. And to put a frequency distribution in your calculator, so to put it in so that it has frequency values instead of to just put in lists, you're going to do stat calc. Your frequency part, oh, I should use the abbreviations the calculator uses. So freak list